Okay, so Chapter 1, Section 5 deals with energy. And Tro entitles this Energy, a Fundamental Part of Physical and Chemical Change. It's important in our conversation at this point because energy is going to help us measure the things that we're trying to figure out, right? So physical and chemical changes are always associated with energy changes as well, and it's gonna help us. We can get sort of some feel for energy at the beginning of our conversation. So energy is defined as the capacity to do work. Now there are a couple different kinds of energy which we're going to probe a little bit more. And the first one is work. Work is a force acting through a distance. So I'm on page 12 in Tro, and work is defined as the action of a force through a distance. The action of a force through a distance. And that's work. Okay, the next kind of energy is kinetic energy, and that is defined as the energy associated with motion. And the third one is potential energy, which is the energy associated with position or composition. It's oftentimes considered stored energy. You can see why potential might be a good term for that. And then finally, thermal energy, which is the energy associated with the temperature of an object or a substance. Okay, so these are the four kinds of energy: work, kinetic, potential, and thermal that we're interested in here. And let's consider some changes when you might have changes between these kinds of energies. So suppose you have some object at the top of a building. Suppose you've got an object which is at the top of a building. You see this big weight up there, 10-kilogram weight at the top? And suppose that it's not moving anywhere at all, right? So if it's not moving, you might consider all of its energy to be in a potential energy, an energy of position or composition. Now, granted, unless the thing is at absolute zero, it's got some thermal energy in it. But for the most part, we can neglect that. Its energy is entirely potential. Now, it falls off. As it's falling to the ground, some of the energy is converted to motion, right? Energy of motion. That's kinetic energy. Now, the closer it gets to the Earth, the less potential energy it has. And so once it hits the Earth, it's got relative to the Earth, zero potential energy. And just the instant before, it's all converted to kinetic energy, the instant before it hits the Earth. Once it hits the Earth and stops, then it's converted to heat as it makes vibrations in the ground into thermal energy. All right, so there's a good example. Another example would be a car. Right, this is a Honda Civic. It looks like it's probably a 2001 or 2002. I used to have one like this. That was white. So you have energy. This is meant to be like a cutaway, so you can see a gas tank back in there, okay, behind the wheel. So you've got all this gasoline in this tank, and it's got potential energy because it's an energy of composition. As the gas is burned up, combined with oxygen in the engine, it lets off energy. So you've got potential energy, which is letting off energy as pressure changes in the pistons, and it's making the engine go, and that converts the potential energy to kinetic energy. And to emphasize this figure here emphasizes that systems have a tendency to go from unstable conditions to stable conditions, and it turns out that the molecules in gasoline are unstable, relatively unstable, right? That's why they burn. And molecules in exhaust are relatively stable. That's why they don't burn. So some of the released energy is harnessed to do work. You can see that the force is applied along a distance. The car moves forward, and so work is done as the object is moved down the road over a distance. Okay, and so finally, I want to sum this up with a law that has been identified with respect to energy, and that's the law of the conservation of energy. It's defined in the following way. Energy is neither created nor destroyed. That's it. All right, so the law of the conservation of energy says that energy is neither created nor destroyed. That's what conservation means. So another way to say this is the total energy of a system remains constant. it can be converted or lost to its surroundings, but it does not disappear. Energy does not disappear. It's never created, nor is it destroyed. And a couple important points to keep in mind, and that is the physical or chemical change is always accompanied by a change in energy. And that's why we need to know about the energy and why it's useful to us. And then finally, systems with a high potential energy have a tendency to change such that their potential energy is lowered and they release energy thereby into the surroundings.